Hello everyone, welcome to the fourth video in this series. In this video I'm going to go through questions 7 and 8 for the higher tier physics paper. Question 7 and 8 is for the separate physics, not for the combined science. Question 7 is on the particle model. So question 7 part A, explain the difference between the term specific heat capacity and the term specific latent heat when applied to heating substances. So explain the difference. So they want you to identify the difference between specific heat capacity and the term specific latent heat. It's 2 marks. You can define what is specific heat capacity and what is specific latent heat, and you'll still get the same marks, same 2 marks. So if you were to define specific heat capacity, is the energy needed to raise the temperature of a material or substance of 1 kilogram by 1 degree Celsius. Okay. Specific latent heat is the energy needed to change the state of 1 kilogram of a substance, right, or material. So how do you write the answer for this question? In simply trying to explain the difference, I would write the answer by saying specific heat capacity involves the energy needed to raise the temperature of a substance, whereas specific latent heat involves the energy needed to change the state of a substance. The key point is to identify specific latent heat is to do with the energy for change of state. Specific heat capacity involves the energy needed to raise the temperature. Part B. Part B. An electric kettle contains 1.41 kilogram of water at 25 degrees Celsius. The kettle is switched on. After a while, the water reaches boiling point at 400 degrees Celsius. The specific heat capacity of water is 4200 joules per kilogram degree Celsius. So the temperature has changed by 75 degrees Celsius. It's gone from 25 to 100. The mass of the water is 1.41 kilogram. Calculate the amount of thermal energy supplied to the water by the kettle. Give your answer to the appropriate number of significant figures. When they say give it to the appropriate number of significance, they usually refer to 2 significant figures. Use an equation listed at the end of the paper. So this is one of the equations that you will be given in the exam paper. So the equation is the change in energy, which is given the symbol delta Q, equals mc mass, specific heat capacity, and change in temperature. Sometimes you can write it as delta T, capital T as well. Now, mass was 1.41 multiplied by the specific heat capacity of water 4200 multiplied by 75. This gives you an answer of 444,150 joules. So in writing in two significant figures, this would be 440,000 joules. 440,000 joules. Part 2. The kettle is switched on and the water continues to boil. After a while, the mass of water in the kettle has decreased to 1.21 kilograms. Remember, the starting mass of the water was 1.41 kilogram. So it's reduced to 1.21, which means you lost a total mass of 0.2 kilograms. The thermal energy supplied to the water was 450,000 joules. Calculate the specific latent heat of vaporization of water. So what is the equation that links specific latent heat? So the energy involved equals the mass multiplied by the specific latent heat. So in order to calculate the specific latent heat of vaporization of water, which is L, if you put this in a triangle, get Q, M and L. So L equals delta Q divided by the mass, which is 450,000 divided by 0.2. So bringing in a calculator just to show you how to do the calculation. Oops, there you go. 450,000 divided by 0.2 gives you 2,250,000. So 2,250,000. Here you can leave it as it is. 2,250,000. Now this was a 8-mark question. A lot of students just managed to get 4 marks. This question, for some reason, a lot of you made mistakes in the calculations, mainly because you failed to identify the change in mass and you used the mass as 1.21 and you wound up just getting one mark. And in the previous question, part 1, most of you did actually manage to get it. You lost 1 mark here, some of you. Right, let's have a look at the marking scheme. So on the marking scheme, substitution is 1 mark for you to multiply those values straight off and to get 440,000 joules. If you just simply wrote the final answer, you'll still get the 3 marks. Now the first part was to do with the specific heat capacity. You need to explain the link between specific heat capacity concerns change in temperature, whereas specific latent heat concerns change of state. That's what they're expecting. So you don't really have to write down the full definition for each of them. The last part of the question, calculating the specific latent heat, you use the equation, make sure that you find out the difference, and they're giving 1 mark if you use the incorrect mass. Moving on to question number 8. Question 8 was on motion and forces and their effect. Question 8, a builder needs to lift a large stone block. Diagram 1 shows the stone block. The mass of the stone block is 130 kilograms, so that's your mass. Calculate the weight. A lot of you made mistakes on this, which you shouldn't have. the equation that involves mass weight is W equals mg. So mass is 130 multiplied by the value of 10. A lot of you are forgetting this, where they don't actually, the question doesn't specify the value of g, and you think that you don't have any values to actually calculate the weight. So 130 times 10 is 1300 Newton. So 1300 newtons. Next part of the question 8. Question 8 part B. The builder uses a wooden plank to lift the large stone block. The plank is uniform and pivoted at its center. The builder pushes down on one end of the plank to lift the stone block. Diagram 2 shows the plank when it's horizontal and is stationary. So remember from the previous question, the weight was 1300 Newton. So you're talking about moments. So the total moment on the left hand side should be equal to the total moment on the right hand side. So if I say that's your left hand side and this is your right hand side, so left hand side should be equal to the right hand side moments. So the main idea is about moments, which equals the force times the distance. This is your principle of moments. So on the left hand side, it's 1300 multiplied by 0.3 should be equal to 520 multiplied by x, which is the distance. So x equals 1300 multiplied by 0.3 divided by 520. That gives you a value of, let's say, 1300 multiplied by 0.3, 390, divide that by 520, that should give you 304, which is 0.75. So 0.75 meters. Again, marks was lost by most students in this question, where you forgot the principle of moments, the equation. Next part of the question 8, part B. Figure 10 shows an arrangement of gears. So you got a gear P, which is with 10 teeth, Q is with 40, and R is with 10. Gear P is turned through one complete revolution. So if P turns once, it will only, so for every teeth that moves, the corresponding teeth also moves. So if you move this once, right, it will move across 10 teeth, so it will actually just move 1/4 of it. So which of the following describes the motion of gear R? So irrespective of how Q moves, R is also has 10 teeth. So when this moves one full revolution, 10 teeth would have passed, and 10 teeth would have passed on this point and on this point, which means you would have the same movement in R, which is going to be speed 1 revolution per second is the same as P. So the answer is B. Next question. Question 8B part 2. Figure 11 shows the same arrangement of with gear R replaced by a rack. So now this time instead of R you have a rack here, which will move vertically upwards. The rack can move up or down when the gears turn. The teeth on the rack are 2 mm apart. Calculate how far the rack moves when P turns through one complete revolution. So when it turns one complete revolution, you would have moved 10 teeth up. So 10 times 2 is 20 millimeters. So it would have moved a total distance of 20 millimeters. They're asking the answer in millimeters, so you don't really have to do any change. Going through the marking scheme for question 8a, part 1, the answer was 1300 and the distance from the pivot was 0.75. And for part B, which involved the gears, the answer was the second choice, which is B, and the final answer was 20 millimeters. That brings us to the end of the video. I will follow this video up with the last part of question 9 and 10 in the next video. See you then.